Welcome back to my YouTube channel. In this video, I am going to discuss the previous year JMN questions, all the physics questions only. Okay, on 8th April 2022, shift 2. Okay, so I am going to discuss the question one by one. Our first question is a hydraulic automobile lift is designed to lift a vehicle of 5000 kg. Okay, air mass is given 5000 kg and area of cross section of the cylinder is 250 centimeter square. Area is 250 centimeter square. Look, here the unit is in CGS. So this is something and this is in SI. So we have to first convert into the same unit so that in next process it is easy for us to calculate. So to make it SI unit, I have to just convert centimeter square into meter square. So that's why I have to multiply 10 to the power minus 4 because 1 meter is 100 centimeter. Okay, now the question is find out the maximum pressure of the smaller piston. Okay, as we know, according to Pascal law, all the point inside this liquid exert same pressure, experience same pressure. That is, del P is same throughout the liquid. Okay, so the formula of del P is pressure formula is force per area. First, we have to find the force. What is force? Force is here the only force act on this body is our gravitational force which is downward. So we put mg and m is given 5000 and g is given 10 meter per second square. So I put 10. So I got 5 into 10 to the power 4 Newton. Okay. Now I put here in place of force I just put 5 into 10 to the power 4 Newton. In place of area, I put 250 into 10 to the power minus 4 because I got it. If I calculate it, I'll get around 2 into 10 to the power 6. So the SI unit of pressure is Pascal. So I just write it as PA. Okay, the first question is complete. Okay, we'll move forward. The second question is the orbital angular momentum of a satellite is L while revolving around the Earth at a height of h. Okay, that means it is saying if this is our earth, okay, it is its center and the satellite is moving around this point. Okay, let the satellite is at this point, so the distance is h, which is from center of earth to the height of satellite. Okay, so let the capital M is the mass of the earth and small m is the mass of the satellite. Now we know the formula of angular momentum, which is L is small m, which is the mass of satellite, into root over of capital G, which is universal gravitational constant, into capital M, the mass of earth, into the height. Okay, height with which the satellite is revolving around this earth. Now the height will become more than its 8 times. So now new height h dash is s plus 8h, which is nearly 9h. Now our new angular momentum L dash is, we put the same formula m, the mass of satellite, only in place of h I just put 9h. If I calculate it, I got, just break it like this, g m h into root over of 9. What is this? This is our L. So this is equation 1. So from equation 1 I got this value is L. So root over of 9 is 3. So simply it's 3L. That means if this height will become more than its 8 time of its initial value, then the angular momentum will be 3 times of its previous value. That is option number 2. Okay. So our next question is, okay, the next question is, the wave emitted when a metal target is embedded with the high energy electron. So it's simply theory. So we can write it is simply X-ray. We know it's X-ray. Okay. So there is no formula to discuss. So it's simply theory. Now the next question is, we have to match column A with column B with their dimensions. Okay. So first torque. Let's find out the formula of, sorry, dimension of torque. We know the formula of torque is force into radius. Force into radius. So the we break force as mass into acceleration. Okay. Into radius is r. So the dimension of m is capital M. Dimension of a is l into t minus 2. Okay. Into the radius is length. So it is dimension is l. If I connect all these, I get it's m l2 t minus 2. Okay. This is this one. So a is double I. That means these two get cancelled. Okay. The next one is our stress. Okay. Stress. Stress is similar as pressure. So it is force per area. So we know the formula of force is, sorry, dimension of force is this one. I will directly put here m l1 t minus 2, and the area is, we can write area as equal to length into breadth. So both are the distance or the length. Okay. So I just put here L square. So I get m1 L minus 1 t minus 2. So from this 1 and 2, we can say the this is m1 L minus 1 t minus 2 which is IV. Okay. So we can write this 4, but I have to calculate all these things. Okay. So first the third one is pressure gradient. Pressure gradient, which is our del P by del L. Okay. That means pressure by length. So have already told you the formula of pressure is same as, sorry, dimension of pressure is same as the dimension of stress. Okay. So I just put here directly m L minus 1 t minus 2. Okay. And the length is, dimension is L. So it become m L minus 2 t minus 2. Okay. Now the one is left. So the coefficient of viscosity is this one. Okay. So we have to find out. We know a formula, force formula is eta into a del v by del y. Here this eta is coefficient of friction, sorry, coefficient of viscosity. That implies coefficient of viscosity is, now I can write simply F divided by A into del V by del Y. Okay. So I just put the formula. Okay. Dimension. So the force dimension is M1 L1 T minus 2 divided by the area is L square, and the dB, which is velocity. So simply velocity dimension is L T minus 1. Okay. So it's divided by, this is y, it's simply length, we just write L. Okay, this L get cancelled, so now it will become m L minus 1 T minus 1. So this is the formula, dimension of coefficient of viscosity. Okay, next question. Now I move to next question is area under velocity time graph gives distance traveled by the body in a given time. Okay, look here. Velocity is velocity is a vector quantity. So area under this will give us displacement. Okay, simply we can say V is ds by dt. Okay, so we can write ds, which is our displacement, is v into dt. So if I take integration, okay, now I got s is integration v dt. So as it is, the velocity has a particular direction, so this one has a direction. So we can say this is the velocity time graph gives us displacement, not distance. So statement 1 is wrong. Okay. Now the second question, sorry, second statement is area under acceleration time graph gives us change in velocity, right? This one is right. Okay. How? The similar process. So acceleration formula is A is del V by del T. Okay. If I start writing del V is, I can write as A into dt. If I take integration, so I get V is equal to integration of A dt. Okay, A dt. So this is the velocity. So our statement 2 is correct. So where it is? It is this one, fourth one. Statement 1 is incorrect. Statement 2 is true. Okay, understand? So the next question. Next question is, okay, it is saying power radiated by from a linear antenna of length L is proportional to, and lambda is the wavelength of the wave. Okay, so the power radiated by antenna, so we can denote it as PR, which is proportional to length of the square of length of the antenna, which is L square, and this power radiated is inversely proportional to the wavelength square of the wavelength of the wave. So if we combine these two, we simply got power radiated is directly proportional to L square lambda square, which is L by lambda whole square. So which is our option D. Fourth one is our correct answer. Okay. Now we just move the next question. The next question is electric potential. Okay. This is from electric potential at a point P due to a point charge. Okay. Point charge Q is given 5 into 10 to the power minus 9 coulomb. Okay. And the potential is given 50 volt. Okay. So V is potential is 50 volt. Okay. Now the question is asking that the distance P from the charge. Okay. If this is charge body Q and this is the point P, I have to find this distance. Okay. We know the formula of a potential is V is electric potential formula is 1 by 4 pi epsilon naught Q by R. This is direct formula. So, and this part is given by 9 into 10 to the power Newton meter square per coulomb inverse square. Okay, now put all the values. It's 50. In place of this, I just know 9 into 10 to the power 9. In place of Q, it is given. It's 5 into 10 to the power minus 9 coulomb. So you have to find just simply R. That implies R is here 10 to the power 9 and my 10 to the power minus 9 get cancelled. So it will become 45 by 50. Okay, this is our distance meter. Okay, if we can make it into centimeter. Okay, the formula is in centimeter. So to make it a centimeter, we have to multiply 100. So 45 into by 50 into 100. So it get cancelled with us 2. It will become 90 centimeter. So 90 centimeter, which is our option number 4. Okay. So the question is asked to find out the distance in centimeter. So that's why I multiply 100 to find out its distance. Okay. So next question. So next question is given. Okay. And we know this is a direct formula. We know this is a direct formula in gravitation. Okay. But we have to find out here. And the question is saying find the acceleration due to gravity at a height h above the earth, which where h is very less than r, which is the radius of earth. Let this is our earth of radius r. Find out at a distance, this point at a distance of h. This distance is h. At this point, find out the gravity acceleration due to gravity. We know the acceleration due to gravity formula is g is g m by r square, which is on the surface of this earth. Okay, this is on the surface of earth. When we go at a height h, now our new gravitational acceleration due to gravity will become g m. So the distance will become r plus h square. And in question, it is given h is very less than r. Okay, so we have to just simply calculate it. It will become g by m. I just take r square as common, so it will become 1 plus h by r to the power 2. Now I'll take into numerator, so it will become g mm by r square, and it will become 1 plus h by r to the power minus 2. Okay, so in question, in by according to binomial theorem, if in the a question is 1 plus x to the power n, where x is very less than 1, then it will become 1 plus nx, but like this. So this question will become, okay, now the value of this part I will put as small g, which is I have written in this equation 1. So it will become g dash as g into whole into 1 minus, as this is minus 2, so I just put here minus 2 h by r. So this is our answer. The higher term will cancel because h by r is very less than 1. So the higher term will h square by r square, or like h cube by r cube, which is nearly equal to 0. So I'll cancel this, and this is our answer. So which is in option number which is our option number 4. So this is our correct answer. Now we move to next question. Question number 39. So it is given that EMF of EMF is given. So EMF is denoted by 0.08 volt is induced in a metal rod of length 10 centimeter. Okay, length is L is 10 centimeter. So first we have to convert this into SI unit because this is in SI unit. So it will become 10 by 100 meter. Okay. Now the magnetic field is given 0.4 Tesla. Magnetic field V is 0.4 Tesla and find out its velocity. Okay. So we know that the formula, direct formula for EMF is equal to BLV. So V is EMF by BL. Now put all these values. It's 0.08 divided by 0.4 into 10 divided by 100. So if I calculate this, I will get it's around 2 meter per second, which is in option number 1. Okay. So on the next question, it is 10 40. The question is asked, work done by a Carnot engine operating between 127 calorie Celsius, 127 degree Celsius and 27 degree Celsius is 2 kilojoule. Means work done is W is 2 kilojoule and its T1 as in Carnot heat engine. So temperature in SI unit it is written as Kelvin. So we have to convert it from degree Celsius to Kelvin by adding 273. So it will become 400 Kelvin. Okay, so our temperature 2 is, we can say the temperature of sink. Okay, T2 is 27 plus 273, it's 300 Kelvin. Okay, now our work done is, sorry, we can find out its efficiency. Efficiency, we know the formula 1 minus T2 by T1, the sink temperature by source temperature. So it will become 1 minus 300 by 400. Okay, if we solve it, I got 1 by 4. And the question is asked, find out the amount of heat transferred by to the engine by the reservoir. Okay, now we know another formula of this efficiency. Eta is 1 minus total work done divided by heat of the source. Okay, heat of the source or the amount of heat which transferred to the engine by the reservoir. Okay, this is we denoted as Q1. Now I just put its value of eta is 1 by 4. It's 1. Work done is already given, which is 2 kilojoule. So I put here 2 kilojoule by Q1. That implies now 2 kilojoule by Q1 is equal to 1 minus 1 by 4, which is 3 by 4. Okay, so Q1 is, oh sorry. So the answer, I have done one mistakes. So this is 1 directly W by Q, not 1. So there is no 1. Okay, sorry, this is my mistake. Okay, so efficiency is work done by heat reserve transfer in the energy transfer to the by the reservoir. Okay, directly this. So we can solve. So there is nothing this one. Okay, so it will become 8 kilojoule. 8 kilojoule. Okay. Okay. So I'll stop here. I'll discuss and 20 more question in my next video. Okay. Thank you.